So hello guys, today we will discuss the one of the topic in designing macromolecules with ML. So first of all, introduce myself. My name is Kamumpati. I'm an artificial intelligence and machine learning engineer, and today we will discuss this wonderful topic of the macromolecules with ML. So macromolecules. So the macromolecules are is monomers. So monomers, linkages, topologies. It's the macromolecules. So macromolecules, and there are three: one macromolecules, biomolecules, and artificial macro and artificial macromolecules. So is the macromolecules is the monomers, linkages, and topologies. This is the macromolecules, and macromolecules is the DNA, RNA, protein, and glycan. So it's the examples of this one. So it's an example of sugar and any one of you in a biomolecules. And artificial molecules is the using in is the artificial one. It's examples of this one. And macromolecules are distinct by the identity and augmented of the monomers and linkages. So biomolecules from the basis of the life. So and artificial macromolecules are ubiquitous and indissoluble. So these are the used in macromolecules. So the representations of these is the linear and non-linear. So linear is the difference is using in this, and this is the words and using it by the numbers, and non-linear is the using in the carbohydrates and cardboard one and CCC. This one of the using. So hierarchical fingerprints of this. So look at this, the atomic level deception, risk deception, this is the hierarchical fingerprints. So the using of this, and molecules is the 10 to the power of the 24 and 29 of the using. So this is the representation. So current representation for limited coverage of the chemical space and topologies and require significant and customization. So this is of the representation. So next one of the similarity computation. So similarity computation is linear biological macromolecules and non-linear biological macromolecules. So this is a linear biological macromolecules is the matrices of this one. So the matrices of the representation of the linear biological macromolecules. So non-linear microbiological is the representation of this one. It is a non-linear one by using the this is the nodes and depth one. So by using this the representation. So methods are limited to biological macromolecules, incorporate evolutionary bias in scoring, and generally do not extend unnatural moment or non-linear topologies. This one of the using. So this is the one of the one. So similarity computation. And next one is the machine learning. So the difference of the using in moleculars and the what is the using of the machine learning. So this is the ChemPro. So this is the ChemPro of the values and representation. So in this one, and next is the represent. So this is my source of data set, and the source of the data set is the explorer data is the taking of the polygram agent is the chemical space. So representation of the property space by the this is the machine learning. So machine learning for polymorphs is restricted by descriptors with limited representations, capacity, requiring customization for new channel space. This is the machine learning approach by using in the source data. Next So monomer representation. So monomer representation is the two physical, chemical and shape descriptors. So another one is the circular fingerprints. So this is one. So two difference of the using. So monomers are represented using the physico-chemical descriptors or circular fingerprints. This is true of the monomer representation. So circular fingerprints by using this and the biometrics values. So macromolecular representation. So this is the differentiating group. So differentiating group is the R1, R2, R3 of the groups. And next one is the monomers. So this is of the pensions. So representations and fingerprint matrices. The fingerprint of the matrices. This is of the one. So macromolecular graph. To the graphing of this one. So first of all is the SMIs and monomers representations, and this next one is the matrices, fingerprint matrices representation of the graph. So macromolecules are represented on the basics of the differentiating group, computation or sequence and topology definition. So this is of the macromolecule representation. So next one is the similarity computation. So this is the similarity computation of the linear macromolecules. So this is of the matrices representation. So in this one of the graphical representation of the matrices. So this is of the representation. Next one is the non-linear macromolecules. So it's the different of this and is of the using these non-linear macromolecules. So this is of the similarity computations. The chemical dissimilarity is computed using sequence alignment or graph edit distance and scored using the Tanimoto matrices. This is of the using in the similarity as a computation. So next one is machine learning. So machine learning, so it's a subfield of artificial intelligence. So discussing of this one. So physics informed model first of all. So physical informed model by using in the equation. So using in the equations to implement it. So simpler models. So simpler models is implemented in the machine learning algorithm. So simply by implementation is the small data. So physical models similar. This is the so small data is enough. But so it's this one. So recurrent neural network. This is of the advanced machine learning algorithms. It's deep learning. So machine learning subset of this one of the deep learning is a subset of the machine learning. So recurrent neural network. So recurrent neural network, it is the use of the test correlation is the using of the recurrent neural network. So next is the convolution neural network. So convolution neural network is the using of the image recognition, image processing. This one using in the CNN. So next is the graph neural networks by using the graphic models by using. So machine learning models for macromolecules are choosing. So according to the data type, data set and size and task. This is the three are using in the machine learning: type, data type, data set and task. This is three are important in the machine learning. So next is our data set. So our data set is the molecular mini. So is the representation of the data set. So it's my data set representation. So next is the motivations of the. So this is of the out. So healthy muscular station, different of the. So the motivation. So next is the model performance, and this is of the my model performance. So seeing this using CNN model, because of the model CNN, it is using in the image processing predicted by the MI5 with the higher accuracy of the by itself using in the CNN. This is of my model performance. So test and match. Seeing this And next is the interruptibility. So fingerprint matrices, so amino acid, this is of the my interruptibility. So next, design of the shorter CPS. So by seeing a graphical representation, so this is of my representation. So motivations, so thermoplastics, thermoset, and a different one. So the deconstructible thermosets, different one. Homoners, cross-linkers, individual formula chains, and cross-linker chain thermosets. So this is of my one. So approaches. So this is my approaches I'm using in the input and machine learning algorithms. So experimental synthesis and virtual screening. This is my approach. And machine learning frameworks. This is my input data, comma sensor and cross linkers, fingerprint descriptor chemist. This is my one. And next ML models I'm using linear regression, logistic regression. So regression models, elastic and ridge regression, different of the models. So this is the model by using in the two train and test. So the output of this one, to predict this one. Glass resistance temperature of this a model performance. This is my model performance. So by using in the graphical representation plot. So monomers, cross linkers. This is my one. So thank you.